Hello. Right. We've got our transformer and linear regulators, and what I want to do today is basically test out these linear regulators, test out to make sure they're going to work with our KiwiSDRs. We've got mains power coming in here, goes through this first circuit breaker here. So this circuit breaker is at 240 volts. It's a 6 amp breaker. It's going to have a few things hanging off. This is just temporary sort of setup. We've then got a iron core transformer, and that's what's going to step us down to hopefully around 12 volts, probably closer to 15. We'll see how it goes. Remember, this has no regulation, it's just a transformer. But we need the voltage to be higher than what we're going to regulate, because these will only regulate down. They're not boost. They won't do any sort of boosting of the voltage. So you need to make sure this is higher than the 13 volts we need. We then have a second breaker on the output of this transformer, and this is just to detect any like short circuits that might happen on the output. So I'm going to wire this all up and give it a go. One thing I'm going to do is, I don't think testing these without a load is a good idea. It'll show a higher voltage than what's expected. So I've got a few 10 watt resistors here that I'm going to wire in, and that should give me, I think, 0.4 amps of load, which should be enough to at least test with. So although this has a red and black, this doesn't have a, this is AC, so it doesn't really have a reference. It's just floating. Just going to test one of them first. So we've got our 12 volt coming out here, enters this board. We've got a full bridge rectifier, so that's going to take it back to DC. This is the linear regulator chip, and then on this side here is the DC output. So I'm actually going to test this open circuit first to get the voltage close to where it needs to be before I put current on it, because I don't want it to generate too much heat. Alright, turn the power on. LED is on. I guess that's a good sign. Let's see what we're getting. Let's actually test the AC side first. So hopefully you can see the voltmeter. So the AC side, we're getting 13.81 volts. That might be a little bit too low because it still has to go through the diodes, but let's see how we go on the DC side. So positive and negative. So I've got 10 volts there. So we want this one to be like 13, at least 13 volts, probably closer to 13.8. So let's just crank this up. There we go, we've got 14 volts. Drop it down to 13.8. If I feel this, it's not getting too hot, which is good because it's not under load. I'll leave that in there. Alright, so let's cut that power, and because there's no load, that's slowly discharging. That capacitor is still charged, but our voltage will be dropping away. Yep, that's what we expected. Let's give it some load. Turn this back on. Alright, let's see what voltage we get now. now that we've got load. Oh, that's still pretty good. That's 13.71. Let's turn it up to 13.8. There, we'll be close enough. Resistors are getting a bit toasty. So let's turn that off for now. You can feel them, they're warm. But that's not warm, which is good. That's what we want. So now I'm going to loop this back into itself, and then we can set next stage of voltage drop. This says AC in, but we should be fine just feeding DC into it. What's going to happen is essentially only 2 of these diodes are going to be active. Now the diodes actually kind of help us in this case because they're the diodes will drop probably about half a volt. So we can actually put this in either way, I believe, and it shouldn't be a problem. This one was 10 volts. We'll make this one here, say 7. Doesn't really matter. Maybe 7.5. And then we'll feed that one in there. So let's give this a go. So this output we want to be 5 volts. So we've got 7.5 going into it. Let's see if we can get that. Should be easy enough. 5.5. Well, this is open circuit at the moment, but let's turn this down. Turn that off. Now we'll add our load and see how much that changes things. Let's test this with the load now. So 5.4. We'll see if any of these are getting hot. So I might leave that for a bit and see how it goes. I just want to test the rise time to make sure the rise time isn't too long, because things will fail if it's a very slow and gradual rise time. Probably about half a second, whereas 3 volts and then finally 5 volts. I want to demonstrate why the linear regulator is important. And I've just got a USB lead that just goes to bare wires. I'm going to hook this up to my spectrum analyzer. The spectrum analyzer, this one, the DSA 815, it has a max of plus 20 dBm and 50 volts DC, so we can feed in DC into it. I'm going to put an attenuator in between, make sure that nothing bad is going to happen. But yeah, we should be able to get essentially a reading of how good a typical charger is versus using the linear regulation. So let me set that up and we'll give that a go. Alright, so I've got the spectrum analyzer set up, got 16 dB of attenuation. We're feeding in essentially the USB signal directly. This spectrum analyzer can take 50 volts DC. Basically it has a decoupling capacitor inside. So we can turn on the USB charger, which is an IKEA USB 3-port USB charger. And it's typically what you'd run like a Raspberry Pi or something like that. And this is just going to give us an example of why we're going to try and use the linear regulators rather than using a switch mode power supply. So let's turn that on. And we can already see there's a whole bunch of peaks there. You can see them drifting over the place, so they're not a constant spur, so we can't just, find one and, know that it's there and it's all fine. Because they're drifting over, they're going to be causing all sorts of interference to the signals that we want to listen to. So, no good. So now let's do the same test, but with the linear regulators and see how that goes. So we're on, we've got voltage coming out here, we can see the LEDs. And you can see we don't have all those peaks that we had before. It looks like there's a little bit of extra noise that we're getting, and that's probably just from the power line. We don't have anything ferrated up, but it's a lot better than what we were seeing on the switch mode power supply that we were testing before. This is why the linear regulators are so important for what we're doing with the KiwiSDR. We want to have really clean power going into our system so that we're not causing interference to ourselves trying to listen to signals. Alright, I'm going to pack up the spectrum analyzer and I might test the KiwiSDR plugged into it and see if the rise time is an issue. So the next thing I want to test is if this KiwiSDR works with the slow rise time of the linear regulator. These little screw terminal little plugs, these are really nifty. Cool. It's in there. Power it from the top one apparently. So KiwiSDR shield, BeagleBone, and you want to power it from the shield. So that should go in there. I'm going to leave that unplugged because I'm going to test the voltage of that connector first. And then I'll test it during as well because it will be under load. So you got 5.38 volts, which is close enough. So let's just try plugging it in first. So network's coming up. And I can see the little lights blinking, which means it's working. That's good. So I'm going to unplug that, turn this off, let the capacitors drain so it's a nice clean test. Alright, let's see how we go. So I'm going to plug this in. We'll flip the power on. We got that slow rise time again, which is a bit frustrating. And I don't think that's booted up because I don't see any lights. I've definitely got 5.3 volts there. So I think that's a fail. Going to need to do something about that, I think. Okay, I've left this running for a bit. I've got all the receivers open, so it should be working as hard as it possibly can at the moment. If we check the voltage on here, it's sitting about 5.03 volts, which is about where we want it to be under load. So I can touch these and they're warm, but they're not burning hot, which is good. So I'm going to get a temperature reading of these. This isn't going to be perfect, but so they're 30.8 degrees, which is good. If we add a second KiwiSDR though, these are probably going to get pretty hot, but this seems to be working okay. I'm going to let it run for a little bit longer, see how it goes. I was doing a little bit of research into these regulators, and on the AliExpress page it mentions that there's a sliding voltage regulator which uses this capacitor, and it has a fairly slow rise time. So potentially what we can do is remove these capacitors, and it might resolve the issue of the rise time being too slow to start the KiwiSDR. What I'll have to do though is remove all the capacitors, test the voltages again, make sure they're okay, and then finally test to see if the KiwiSDR works after that change, and then also see if there's any noise difference from removing those capacitors. Alright, so just going to use some solder wick to try and get rid of these. I can just clip them if I don't want to reuse them, but I might need to. Moment. We'll see how this goes. Might need to add some solder since we don't have flux. Cool. Alright, so let's test the voltages on this and see how they go. Now if I turn this on, oh yeah, that came on like instantly, but I wonder how noisy that is. Let's find out. I've got the KiwiSDR plugged in. Turn this on, see what happens. Ah, that's much happier. That started up. We're a little bit on the low voltage side, so I might just nudge that up. I'm going to get the spectrum analyzer out again, and we'll test how clean that power is. And it's all plugged in, turned on, and I'm not seeing any noise on here, which is really good. So that seems to have fixed the rise time, and we haven't introduced any extra noise into the system. So I'm pretty happy with that, and that will be it for the moment. We know this works, and it seems to work well. Copy yours.